Good. When you throw a mango up by a ball, what happens to the mango and the ball? It comes down. You understand? Because there is what we call gravitational force. There's what we call what? Gravitational force that acts on that ball. You understand? Anything that has mass, whenever you throw it up, the force of gravity that is acting in the space of the earth will draw such ball down or the mango down. Is that clear? So this force of gravity acts whenever there are two bodies. You understand? With masses. The earth has mass and the ball has mass too. You understand? So whenever you throw the ball, because of the mass of the earth and the force of gravity, it draws that ball down. There is force of gravity acting between the planetary bodies. You know what the planetary bodies are? The stars, the sun, the earth. You know we have 9 planets, isn't it? And all of them are revolving around the sun. There is a force that keeps them in balance. Is that clear? So because of the heavy mass of the earth, almost everything that you throw up in earth is being acted upon by the gravitational force of the what? Earth. And that is what draws it down. You cannot throw something up and it continue moving up. Once you throw it up, it will do what? It will come down because it is being acted upon by the gravitational force of the earth. Is that clear? Now, there are 2 types of forces. We have what we call contact force. Those forces that you feel whenever there is contact. And we have what we call field force. Those forces that you don't need contact for you to feel them. You know the force known as frictional force? When something rough is trying to move on top of another thing. You understand? They are in contact. So this one is preventing this one from moving freely. That is contact force. Frictional force is an example of contact force. Now, if you bring an iron and keep, then you keep magnet. The iron and the magnet, are they touching each other? No. But what will happen? It will attract it. Because there is what we call field force. The force that acts at a distance. You understand? You don't need to touch the 2 of them, but it's drawing it. So magnetic force or magnetic field is a field what? Force. The same thing with the earth gravitation. You understand? Gravitational force is also a field force. Because when you throw the mango or the ball, is it touching the earth? No, but the earth is drawing it down. So the force is acting at a distance. Is that clear? So, and that brings us to gravitational field. This is the region or space around a mass which the gravitational force of mass can be what? Felt. Anything that you throw on the earth gravitational field, we are staying in the earth gravitational field. You understand? So whenever you jump up, you will feel the gravitational field of the earth. How will you feel it? Because it will do what? Draw you down. You understand? If you keep a magnet and you go and keep something like iron, the iron is going to feel the magnetic field of the magnet because it will do what? Draw it. You understand? So that region around that magnet, where whenever you keep an iron, it will be attracted. That region is known as its magnetic field. The same way, the region in the earth where everything you throw up must fall down is known as the earth magnetic gravitational field. Is that clear? Gravitation is the force of attraction. Force of what? That's why when you throw something up, the earth is going to attract it back down. Gravitation is the force of what? Attraction, exerted by a body on all other body in the universe. It holds together planets, stars, and what? Galaxies. I already explained that. Huh? Now, we have what we call Newton's law of universal gravitation. That is the law that governs gravitation. Is that clear? And this law simply states that every particle in the universe attracts every other particle with a force that is proportional. That is what? This is the proportional sign, is it not? This direct proportion. Proportional to the product of their masses, m1 and m2, and inversely proportional all over to the inversely proportional to the what? Square of the distance r between them. Is that clear? So this is known as Newton's universal gravitational law. If you want to remove the proportional sign, you have to introduce a what? Constant. If you want to remove the proportional sign and replace it with equal to sign, you have to introduce a constant. That constant is known as what? G, known as what? Universal constant of gravitation, or you can call it what? Gravitational constant. The value of this G is equal to 6.67 times 10 to the power minus 11 Newton meter squared per kilogram square. Is that clear? So we are doing this formula, let's say for these two masses, M1, M2. You understand? The force that attracts this one to this one is equal to the force that attracts this one, even if this one is bigger than this one. Let's say this is F, and this is a mango that you threw up. You understand? The force attracting the earth to that mango is equal to the one attracting the mango to the what? Earth, F. And that is this force. You understand? And this force acts in line, joining the centers of both of the masses. Is that clear? So we are going to be using this formula to solve subsequent problems in gravitational field. Is that clear? So take note of this formula. F is equal to what? G M1 M2 all over what? R squared. Where M1 and M2 are the masses of the two particles. If you are talking about gravitational attraction of mango on Earth, this M will be what? Mass of Earth. Whereas this one will be what? Mass of the mango. Is that clear? And R will be radius, which is the distance between the two masses that you are considering. Is that clear? So take note of this formula. Subsequent classes we are going to be using it to solve a problem.